Welcome. In Getting this up today, I am Dr. K. Chandrakanta, Assistant Professor at Department of Physics, Madanpalli Institute of Technology and Science. Today, I will introduce an introduction to Spintronics. My subject is physics, so it's very familiar to me, and I feel it's fortunate to introduce the Spintronics, the most demanding, and nowadays it is the increasing requirement for this microelectronics and technologies. So we will start what is spintronics and what is the daily to day use and how we can make our efforts to make it is a very useful for electronics and what is the resource exposures are there. We will explore one by one. So first we will start from introductions, and then we will go why and what is Spintronics is, and what is the need of the Spintronics is required, and what are the Spintronic devices we have, and what is the future prospects based on this. And we will summarize, then we will conclude the sessions. So let's start. What is Spintronics? In the Spintronics, the word is spin is there. So you are very familiar about electron has mass, charge, and spin, and we are mostly have used these things mass and charge. I think we are that much of not familiar with spin of electron, but the day-to-day life applications, what we are using our surroundings, any electronic devices, gadgets, these are mostly we can see the charge is most an effective uh, use of these devices. So there is a requirement of these charge dependent electronic systems are increasing day by day. So if we think without why we all are focused on the charge of electrons. So that's the matter. We are focused only charge of electrons. But if we focus similarly, there is a spin of electrons also there. So how much our efforts is there to study the spin of an electron? So we will explore the spin part of electron. So we know electron has a spin. A spin is nothing a direction where they revolve. So this spin of electron is first experimentally verified in Stern-Glass experiment in early 1920s. And after that discovery, still the application based on spin, I feel is very rarely available. But now, due to overuse of the charge part of electron, there is a demand. We should explore why not the spin part can be used a replacement for the charge part of the electron. So, in this sense, I will introduce how the spin part will be useful for the electronics, microelectronics, in comparison to charge part of electron. So let's make what is the spin? The spin makes an electron a tiny magnet. It is nothing but a electron itself is behave as a magnet if we consider its spin. So now we will switch from the charge application of a electron to spin application. So I already told why you are interested to switch from charge to spin of electron, because the spin is a very good replacement of a charge. Why? Because the charge is a conventional electronic device. Up to now, whatever the electronic device are used, they mostly focus the transport of electrical charge of electron. And in this way, you can see these microelectronics are mostly clumsy, heating produces, and it is required so much of space what we have relay up to now from early 90s. If that's why the scientists think why we have not to switch, we have to why we rely on the same complex and chaos electronics. We can't replace this charge part of an electron with spin. So in this way, we will now add a spin degree of freedom to our electronics. So it will provide a new effect where we expect the clumsy electronics we can see in the gadgets like transistors, diodes, and motherboards. These all charge-based electronics, we can we replace with spin? Then the question, if we replace, what is the our advantage on this scenario? The advantage we can tell, first thing is that energy. We all are very familiar that day to day life, the energy consumption is increasing. And how we can use a less energy and we expect more application? That is the fundamental question nowadays arises in all over the world. So the first thing we have to do is we have to consume less energy. This consuming less energy is somehow related to spin of electron. As I told, charge is very much effective to heating. In microelectronics, in mobiles, these all things are due to transport property of electron, it makes heating. And in the heating sense, we lost a lot amount of energy. Another sense I told, you can see a motherboard. In the motherboard, we see lot of electrical circuits are there. And these electrical circuits makes it clumsy and we have not overcome the heating also. So in this scenario, the scientists think if we exchange our transport property with spin, that means they are adding a new degree of freedom to electronic system so that we can replace the charge with spin. So now you can expect how much spin we can reduce the energy consumptions, we can reduce the heat, we can reduce the space, we can reduce the system from micro to smaller, even more smaller way. And we can use this very high space gadgets to in the smaller scenario. So in this sense, the spin takes a very big part. Nowadays, the explore the spin part of electron in the electronic system, in the gadget, they are very much interested. So we will explore how the spin part of a electron can be useful in this electronics. So in this sense, I will tell spin transport property. So this spin trans property or spin based electronics is nothing as a spintronics. Now the spintronics is a mostly demandable and widely acceptable topic in the world because I told it is going to replace the charge of a system by spin. So this concept, how it came to mind first, how this think we have to use the spin part of electron without the charge. So we can we the question arises, can you use the spin part of electron in the place of charge? Can it be our electronic system can be replaced by this? So this question arises from the first Moore's law. Number of transistors doubled in every 18 months. We can see how the transistor requirement is using every 18 months is doubled. Then you can expect up to next 10 years how much transistor is required. And if you see, if you this much of transistor we can accumulate, how much the electronic waste will be come outside. This is a very alarming to us. We have to think a better to replace these transistors because these transistors are mostly the semiconductor device and this semiconductor device is mostly depend on the charge transport property of electron. So to address how to replace the transistors as specified by Moore's law, how can you overcome? We have to overcome unless it's a very alarming to us because it will be generate a very high electronic waste. So to do this, we have to take the part of a spin. And I have already told the most important thought that are generated in a mind to use the spin is complexity. Complex chip design, power loss, these all the drawbacks that charge transport of electrons brings us. So now you have to think, can we address these questions? Can you replace Moore's law and complexity by spin? Yes, of course. That's is spintronics. So that's only the spintronics system. We have to explore. what is spintronics, how the spin part of electron we can use as a transport property, not the charge transport. For that purpose, we will switch how we will use these systems. So you can see here, I told this is the requirement of transistor, how is increasing day to day life. And you can see here where we are now, it is double and double and double times. So there have to find a solution, because it is a very alarming paper. How to find this solution? The solution is nothing but spintronics. For the now, we have to use the spintronics, unless we can't overcome this problem. So now you will explore how the spintronics will explore it. So first, spintronics is discovered in 1988. As I told, spintronic is the spin concept of electron is already discovered a large time before, but it should be used in a device. It takes nearly 100 years. So 1988 in France, first they discovered GMR. It is a giant magnetoresistance, and this device is fully based on the spin part of an electron. So the spintronics birth, we can tell it is a 1988. The first scientists see that the GMR, a instrument that is based on spintronics, where they used the spin part of a material to create the resistance. G means it's a very high and resistance. What is magneto is there? I told spin of electron nothing but a teeny magnet. So this magnet creates resistance, and that resistance is very large. That's why it is giant magneto resistance. And we can see this is a not charge based, it is fully spin based. So in this spin based, we can see here there's a two layers is there, two layer of magnetic materials, and they both have same orientation of revolving, or we call it as a spin. So this same spin, two systems are layered with a new material. So it will create the resistance to pass or to flow a electron. So giant magneto device is made of at least two ferromagnetic layers separated by a spacer layer. So these two ferromagnetic layers will give you the spin of a system, and the middle part is a spacer layer where we can expect our resistance. If we switch the spin of a system, its resistance will change. That is the most interesting thing about spintronics. You need not to apply that much of charge, electric field. You have to switch by a small electric field or whatever, maybe magnetic field, the spin of electron, so you can switch the resistance. That's why GMR is a widely acceptable nowadays. So when magnetization of a two outside layer is aligned, you will get low resistance, and conversely, when magnetization vectors are antiparallel, you will get high resistance. This is the first instrument where spintronics is used. So now this thing, why we need the spintronics? Here answer is simple. The performance improves with smaller device. As we all require that electronic device should be small, as small as, so we can carry wherever we can. So you'll see now the demand to make smaller device is increasing day to by day. So if you use the spintronics, we can use the electronic device as much small as possible. So it make you the low power consumptions. And second thing, how spintronics does not require unique specialist semiconductor. That is the advantage. It does not require any semiconductor devices, because semiconductor devices are based on its charge only. So this is the fundamental applications where spintronics fully based on the spin part. It does not require any semiconductors, and switching time is very less. Suppose for charge you have to change the voltage, but here simply spin the spinning of electron, or switching the electron spin. It's very easy. We can switch the electron spin, and that time is very less. So time is very less means we can expect a lot of work we can do in our computer if you use spintronic based system within a fraction of a time. So this is the main advantage we can expect here. And in comparison to normal RAM chips, Spintronics RAM chips will increase the storage density by a factor of 3. It is already, they have studied these things because the speed is very high. And I told here the system requires smaller space in comparison to charge. So we can increase our capacity in comparison to charge devices. So these are the needs not only we require, this is the need we have to do in our electronic system. And this will be replaced by only the spin part of electron. So where up to now they are using. So they are using up to now in MRAM, magnetoresistive random access memory, spin transistor, quantum computers, Spintronic scanners. This is MRAMs. Nowadays they are replacing the RAMs with MRAMs. Magnetoresistance, nothing but a Spintronics device, random access memory. So we can expect the timing speed is very high. We can expect the space is very high and the size is very less here. That's why they are replacing. You can see the image of MRAM. This is that prototype we can use to up in our upcoming times. So they are expecting this should be very useful for our time. So I told all the storage device of a size of atom working a speed of light. So this is the very use for the spintronic system. So where other can you can use the spintronic system? You can see here the spin transistors are there. So I have seen that according to Moore's law, transistor use of transistor increasing day by day. So this spin transistor size is very less, very small size, because the spin of electron, how much the space we can take, spin of electron is required. Nothing required a very complex and charged system. That's the spin of transistor is very important to replace with what the semiconductor transistors. So we can expect these systems will evolve more in the recent future. So we will see what other you can use. Uh, so you can see in quantum computers nowadays they're replacing this charge part with the spin part. You can see here they want to do multiple tasks using quantum computers, and I can see the quantum computer is only based on the spintronic systems. They're using more focus on spintronics apart from the charge, because in that much of tiny, the heat generation, you can expect the charge transfer system is very high. That's why they are very concerned to use the spintronic system in quantum computers. So you can now expect quantum computers are revolving with spintronic system. So it should be a very effective research field we have to explore on this system. Apart from this, in medical field also they are using the spintronic device like spintronics scanners. They can that because the spintronic part is very small. It's very small, so they can sense the cancer cells. They can detect even though they are very small in number, because the spin part of electron will do this work. So this is the thing advantage based on the charge system. So we should explore how the spintronic system, you can expect the spintronics can be replaceable to charge transfer of a system. So we expect these are the most fundamental application now evolving in the world based on the spintronics. It's a very a long run we have to do based on spintronics, not on the charge transport. So the future perspective of spintronics is a huge race going on around the world to explore the spintronics. So we have to explore not only the charge, we have to take a step forward to see the spintronics, what we can do, what we can explore. And application of high capacity hard drives also based on this. In the market of quantum computers, now we all know the future is market of quantum computers, and these quantum computers are nothing in without using the spintronics. So I can expect we should more focus on the spintronics, and we explore more on this the spintronics device apart from the charge transport electronics. In the summary, I will conclude the spintronics may be the best mechanism for creating here small devices, and spintronic has already some success stories like giant magnetoresistance. I told is 1988 they have already shown the experiment how the resistance can change the spin. And quantum computing recent trend is going on. We have to explore, we have to do with these things. So that's why the spintronics is very important for quantum computing. So we have to go with these things. And other potential I've shown the biosensor, magnetic sensor. So these are the some of are successfully they have manufactured, and some are on the way, and all the world is on, they are working to get the spintronic systems. We should know So this is the fundamental thing we have studied, or we have shown this here. So we have to explore on more the spintronics, so it can replace the charge transfer of a system. So you can see here, silicon electronics is already old, so we have to now evolve with the spintronic. It is coming to world. It will be replaced, it would one day, to this the total silicon electronic. The silicon electronic nothing but the charge transport. So we are expecting that spintronics will explore, and it will be replaced one day, and we will be also go with flow with spintronic system of our electronics devices. This is the things, and we have to feature this. And thank you for this session, all of you.